Okay, welcome to another video in chemistry. In this video we're going to be reviewing the geometric structures that we went over in class and in lab. So this is part one of a two-part series where we discuss these shapes that I have listed here. There's 7 in total. This first video is going to discuss the first 5 shapes. Okay, I tried to arrange these in the most logical way possible, as to maybe reduce some of the confusion as to the names of these shapes and where we derive these names. Alright, so let's go ahead and dive in. Well, actually, before I start, I want to talk a little bit about some of the things I'm going to be discussing in the video. Along with the geometric shape, we're going to use some various molecules as examples. We also want to talk about the total pairs of electrons, the total which comprise the shared pairs and the lone pairs of electrons. Okay, so recall that the shared pairs of electrons are your sigma bonds. These are the ones that make an actual bond between two elements. And then your lone pairs, it'll be signified as a little bubble with 2 dots, and those dots represent the electrons that are not paired with anything. Okay, and again, our total pairs are shared plus lone equals total pairs. Okay, all right, so let's dive in. Let's first take a look at a linear molecule. I have beryllium chloride as an example. You'll notice that I have chloride on both ends of beryllium, and it's a perfectly balanced, stable molecule. Beryllium doesn't have any lone pairs. Okay, so lone pairs affect the geometry of these molecules a lot, and I'll show you an example of that in the next few molecules. But you'll notice here we have 2 shared pairs of electrons signified by the lines. Okay, we have no lone pairs. So in total we have 2 pairs, and each of them are shared pairs. Now this molecule, because of the lack of lone pair electrons, this molecule remains this shape. We call this a linear molecule because it makes a line. Okay, linear. So also take notice of how far apart these molecules are. Recall that electrons are a negative charge, and when we have things that are of like charge, they don't like each other, they repel. So these electron pairs have separated themselves as far apart as they possibly can in this particular geometric shape, which is 180 degrees away from each other. Okay, now let's take a look at a water molecule. Let's see what happens when we add lone pairs. So you would think H2O, right? We have 2 bonded pairs. You would think that this is the shape of the molecule, but if you look at the center element, oxygen, it has 2 lone pairs. Alright, so in total we have 4 pairs. 2 of them are bonded, and then 2 of them are lone pair. Okay, now notice what happens to our bonded pairs. So we have a lot of electrons that are bunched in together in this molecule, and they don't like that. All those like charges, all those negative charges are going to begin to repel each other, and they're going to repel each other apart from in a way that will stabilize this molecule. So notice what happens to the bonded pairs. They get pushed down. Okay, so those lone pairs affect the geometry. Recall how I said in the beginning of the video how lone pairs and these molecules affect the shape that these molecules take. This is sometimes called the Mickey Mouse molecule because, well, you know, it looks like Mickey Mouse with the big ears. So the lone pair electrons repel the bonded pair, bending them down. This is called a bent molecule. Okay, and again, this is opposed to your linear molecule, which doesn't have lone pairs. Okay, and this is where we get that term bent. Okay, all right. So let's take a look at a trigonal planar. Trigonal meaning triangular shape that it makes. Okay, and then planar meaning that it's a flat plane in terms of geometry. So our center element is aluminum, surrounded by 3 chlorine atoms. Notice that I have 3 bonded pairs. Okay, so in total I have 3 pairs. All of them are bonded. No lone pairs. Okay, so that makes a trigonal planar, a plane. Just think about a flat sheet of paper, how flat it is. It doesn't have any 3D elements to it. It's just a flat sheet. Okay, likewise, this molecule is flat. Now, look at what happens with the trigonal pyramidal. Okay, so I have a central element of nitrogen, and then I have 3 hydrogen atoms bonded to it. Now notice, compared to my previous element, aluminum chloride, look at the way these bonds are shaped. The geometry is a little bit different, and the reason why is because I have a lone pair. That lone pair, those electrons, are pushing down on the bonded electrons, changing the geometry of the molecule. So I have 3 bonded pairs, and then I have 1 lone pair, giving me a total of 4 total pairs. Okay, trigonal pyramidal. So trigonal pyramidal, I have at the base of this molecule, I form a triangle shape, and then I can draw lines to the top, making a pyramid. Okay, so that's why we get trigonal pyramidal. Now, in the next shape, tetrahedral, notice what happens. Instead of having a lone pair, we're going to actually make another bond. Actually, before I go to that, trigonal pyramidal. This is the basic trigonal pyramidal shape that we have made from this molecule. Okay, we have our base triangle, and then our 3 are making lines up to our lone pair, making that pyramid. Now, like I mentioned before, instead of having just 3 bonds, this time we're going to bonded pairs, we're going to have 4 bonded pairs, 4 sigma bonds. So now there are 0 lone pairs. All of them are bonded. Now the geometry changes just a little bit, and the name changes. Now we have a tetrahedral, which is a 4-faced or a 4-sided polygon. Okay, now where do we get that? So our first face is in the front, the 3 hydrogens making a triangle. The second face are the 3 hydrogens on the back side, on the right side back, and then on the left side back we have another face, and then we have our base. So I understand that this might be a little confusing looking at it this way, so I gave you a different shape here. So here again is our first face, which is formed by the base hydrogens, and then we have a back set of hydrogens that make the second face, the third face, and then the fourth face. So that's 4 faces. That's tetrahedral. So let me back up just a second. So that's our tetrahedral, and again, this is the shape, this is the molecule that makes that. So tetrahedral is different from trigonal pyramidal in that the tetrahedral has 4 bonded pairs, whereas the triangle pyramidal only has 3 bonded pairs and 1 lone pair. Okay, so keep that in mind when you're differentiating these molecules. Okay, here's a third face, fourth face. Okay, so that does it for part 1. And the next video we'll discuss part 2, where we finish off the last 2 molecules. Thanks for listening, and good luck in your studying.